Good evening, Dr. Sonalgar, and welcome to Biochar channel.
Yeah, good
So we
evening.
had, good evening. So we had very good discussions about earlier on the characterization and various aspects of biochar. And today, another important topic that we would like to discuss is on biochar pelletization. So the biochar, when it is formed, it may not be in the form of pellets. It will be in various sizes. It can be in powdery form also based on the feedstock and other nature of the biomass. But ultimately, this has become one important aspect in as a product when people are selling this for various applications and especially the transportability or even handling this material and sometimes convenience of applications because of uniform of size of the pellets that are created. So it has umpteen applications. So first let us discuss on what are the various methods of this pelletization. What is that binding material that we use in biochar pellets, and what would be the calorific values and other things that would improve in the process. So all these aspects about the biochar pellets.
Right, sir. So this is a very important topic, sir. So let us first understand about biomass and biochar, because this biochar we are obtaining from biomass only. So we can make pellets out of biomass also. So we can make pellets out of biochar also. So what is the difference in a biomass pellet or a biochar pellet? So we can differentiate it in terms of moisture, in terms of volatile, in terms of ash, and in terms of calorific value. If we take, first of all, let us take biomass pellets. So in biomass pellets, the calorific values are lower because it has high moisture content, it has ash content, and it has volatile content is high. So, if we talk about biomass pellets, then the volatile matter is somewhere around 60%. And if we talk about moisture content, then it is around up to 15 to 20% moisture is there in the biomass. And if we talk of the calorific value, then it ranges around, say, 3,500 kilocalories per kg to somewhere around 4,000 kilocalorie per kg. If I talk in megajoules, then it is somewhere around 14 megajoule to 17, 18 megajoule per kg of calorific value. Whereas in the same comparison, if we talk of biochar pellets, then biochar pellets are formed when the biomass is pyrolyzed. On pyrolysis, moisture goes away, volatile matter goes away. What remains is a fixed carbon. So this carbon content increases the calorific value. So if we talk of biochar pellets, then biochar pellets moisture content is lesser. If you say for the moisture content, then it is around, say, 5 to 8% moisture, you can say. If you talk about the volatile matter, that is also very less. That is around, say, 15 to 20% it remains. If you talk of the fixed carbon, then the fixed carbon now increases to around 60%, which was initially 20% in the biomass. So this fixed carbon increases the calorific value to somewhere 6,000, 6,500 to 7,000 kilocalories per kg. In megajoule, if we say, then it becomes around, say, 25 megajoule to 28 megajoule per kg of biochar. So pelletization is a process to convert any feedstock into pellets. Now, second thing that comes is very commonly used word is briquetting and pellets. So we should understand the difference in the briquettes and pellets as well. So briquettes are anything that is larger in size. In case of, if we talk in terms of diameter, then anything greater than 25 mm becomes the briquettes. Whereas in case of pellets, they should be lesser than 25 mm, and the length of the pellet should be between 3 to 40 mm. This is as per the ISO code for solid fuels. So the pellet should be long, irregular ants it is classified as a one which is length has a length width is lesser than 25 which has rough endings, cylindrical in shape, formed by compaction. So which is more densified. So these are pellets. Briquettes are also densified briquettes, but they are having a diameter. Minimum is 25 So anything that is bigger in diameter, they are bigger blocks. They are also densified.
So one of the things, as you mentioned, there is a difference between the biochar pellets, biochar briquettes. So otherwise, the briquettes and pellets that are done by any biomass, that's a traditional way. Usually, there we look mainly for using as a fuel, one of the major purpose for biomass pellets and briquettes. But
Right.
here, biochar pellets, especially, even they could be maybe a round form also. They can be spherical also. Yeah, if possible.
Yes, you can say because the size ranges from 5 to 40 If we talk of the length, then it ranges from 5 to anything to this
Shape could be, they
40
may
mm.
not be cylindrical kind of shape.
Yeah, it can be cylindrical, it can be small cylinders, it can be anything.
Yeah, it can be anything. So here, I think this is not for just combustion or something, because biochar, when we see the carbon crates and all that, the applications are many as it is. Whereas biomass, say for composting, we apply. That is one of the basic things. But here, biochar pellets, use and reuse concept, it comes into picture. Here, right from environmental applications, even agriculture, soil amendment application, many point applications, including as a scrubber or even as activated carbon, even in our cartridges, maybe including purifying that biogas for CNG. So I think there are umpteen different models that are coming into picture, where at the end these pellets can be reused again for soil amendment, or maybe in construction industry we can adopt, or various ways. So that way I think here the dimension, yeah, otherwise what we speak about, like any barbecue kind of thing, burning them in a chulla as a charcoal stove, but not here much we are discussing. So they can go in a way if yeah, they are using. Nobody is preventing them to use. But ultimately, when we look at these credits and the systems in place, because we are looking for long-term carbon sequestration, here I think the broader picture is emerging as a best solution for environmental, soil, or even for industrial applications, or even livability of the people. So I think in this context, I think biochar pelletization has lots of value than looking as it is. So you can add certain things on this aspect.
Yeah. So whenever we do pelletization, so our main aim is to densify it because raw biomass, or you can say the biochar, if you see the powdered biochar, it is difficult to transport, difficult to store. Even if we are applying for soil amendment, then rain, storms, they are taking it away. Even while adding fertilizer, tilling, every time dust is formed, dust of biochar is formed and it is lost. Then 30% of the biochar, it is reported that if we are applying it in the raw form, in the powdered form, then it is not utilized by the plants. It is lost as it is in the environment, causing pollution also. The particles are so fine that they are inhaled by the people. So basic purpose, be whatever the application is, the basic purpose of pelletization is to densify the energy, is to increase the energy content, is to make transport easy, storage easy. So this is the basic purpose of pelletization. Now that pellets can be used for scrubbing purpose, for H2S removal purpose in the bio-CNG plant, as you very well said, or for even soil amendment, people are adding pellets only instead of adding loose Biochar, powdered biochar, they are adding now pellets. They are making pellets and adding. And the studies are also focusing on the effect of the biochar pellets first year, second year, third year. This is so because pellets that are added to the soil in the first year may not give you the results because they are compact. It takes time for the microbes to act on the biochar pellets and to disintegrate it, to reach to their core. So there are studies that are indicating, as for sugarcane bagasse pellets, I was reading one paper in which sugarcane bagasse has been converted into biochar pellets, and it is applied in the field, in the cotton stalk fields. So in that area also, they were reporting that in the first year the effect was negligible because the pellets take time to disintegrate. So if you see the undesirable characteristics of biochar, we know biochar is a prized product, everything is good. But at the same time, undesirable characteristics are see the low bulk density. The bulk density is very less. If you talk of transport and storageability, if you are storing powders, then a lot of space will be required and very difficult, great difficulty in storing huge bags, and storage space will be required much more. Then you have troublesome co-firing with coal. If you are firing it with coal, then firing powders with coal is again a difficulty. The combustion length will not be, burnout will be very fast. So these are the undesirable characteristics. Dust production in the fields will be high. Low energy density will be there for the biochar also if it is not compacted. So considering these things, we are supposed to convert it into pellets, though it has a cost. Definitely, pelletization has a cost, but its advantages are much more than using biochar in the powdered form.
Yeah, now coming down to the various methods of pelletization, we have lots of machinery because originally they were meant for converting biomass into pellets and briquettes like that. So that's not an issue. But I think same materials are being used for as binding agents also. But in this process, because biochar is a carbonaceous and fixed carbon, it is something different. But once we add something called lignin, starches, or vegetable oils, or any other bio-based binders to this biochar, the characteristics will definitely change. That could be the reason why you said that the volatiles could be high in this. Yeah.
Yeah. So if you talk of the binders, because biochar cannot bind, it is hydrophobic in nature. So to bind the biochar particles, as we can see for the coke, for the coal also. I will give an example of coal. We have different grades of coal. We have anthracite, we have semi-anthracite, then we have bituminous coal, then we have lignite. So if we talk of bituminous coal, and bituminous coal is somewhere around say 60% of carbon in it. Anthracite is the highest percentage carbon, that is 80% and above. And if we talk of lignite, lignite is just 25 to 30% as received coal, having a carbon content of 25 to 30% and a high ash content of 20%. So if we talk of lignite, that it does not have any coherence properties, and you cannot bind, you cannot cake, you cannot convert it into pellets. So with the lignite, you have to definitely add a binder to convert it into pellets. In the similar way, biochar, you cannot bind biochar within its own molecules. You need to add a binder. So binder is any substance that brings the molecules together. Various forces comes into play. Hydrogen bonds are formed. Van der Waals forces comes into play. So anything that binds is a binder. Now, if we classify binder, what is a binder? Then anything that has a caking ability or coherence ability that will bring these two, then it becomes a binder. The binder should have, what are the qualities of a good binder? It should have it should impart a good mechanical strength. Mechanical strength should increase, thermal stability should increase, whereas the combustion performance should also improve. So if we talk of combustion performance, the burning of the pellets should be clean and it should not be smoky. So, what do you mean by clean burning, and from where this smoke comes? So, whenever we are firing any pellet, then you have to ignite it, and you have to wait for the for it to catch fire. So when it catches fire, when volatile matter, it is not, I'm not talking about the volatile matter of the biochar. I am talking about the volatile matter that is formed at the top of the pellet that catches fire to ensure the complete burning of the pellet. Means it is the, you can say, the part of volatile that escapes before the briquette is heated to the kindling temperature. Now where is this volatile matter comes? It is, if it is a part of the binder, then binder should have low boiling point material in it, that then only it will give some volatile matter, and then only it will catch fire easily. So a binder that is giving you lot of volatile matter at a very small temperature will always give you a smoky burning. Lot of smoke will be produced. So the binder chosen should be such that it should have a clean burning, non-smoky, high mechanical strength, high thermal stability. Combustion performance should be very good, and above all, easily available. Cost is very important aspect of a binder, that it should not be very expensive, that the product cost increases, final pallets becomes very costly. So these are few of the properties of a good binder. Secondly, ash. When we do combustion of the pellets, then ash is produced. So if a binder is inorganic, I will tell you the categories of the binder also. So one of the categories inorganic binder, such as clay is added to bind the material, or the bentonite clay is added. So these are the inorganic binders, which increases a lot of ash content. They provide good mechanical thermal stability, and mechanical stability is also good. But at the same time, they don't contribute into the volatile matter. Their calorific values are less. At the same time, they,
Sometimes maybe the synthetic binders are also added. Maybe plastics are also added.
yeah,
In it.
that comes in the polymeric binders. That is the organic binder basically.
Yeah.
So I will show you what, I will share my screen in a short while to show you the classification of the different binders. So the binder should be such that it should have a good cold strength. Means once it is cured, it is left at the ambient temperature, then the briquettes or the pellets should not disintegrate into the ambient conditions. And it should have a high bond strength. It should absorb, say, if you are talking of coal, then sulfur is also present in the coal. So it should absorb sulfur also. So these are some of the high heating value. So these are some of the properties of the binder that we always look for before choosing a binder. So yeah,
Maybe some other applications, like when we are applying as a bedding for animals, let us say in poultry sheds or animals, something like that. So then the pellets will be more convenient. And what I found is another important aspect in urban rooftop gardens or in hydroponics like that. So these biochar pellets will be very convenient because when we put water, then they won't flow. The biochar doesn't
holding
flow.
capacity will be good.
Yeah, so that way I think there are umpteen applications of this thing. So you could show that pictures of this biochar pellets and other values. Yes.
So if we see, there are three type of binders, you can say: inorganic binder, organic binder, and composite compound binders. That involves organic and inorganic both. So let us talk about inorganic binders first. So most common is clay, bentonite clay, or sodium silicate or water glass. If you see the percentage, mixing percentage, then it is 6 to 8%. And for the sodium silicate, it is up to 1% only is required to mix. What is the properties that it imparts? Briquette compressive strength is poor, water resistance is low, and waterproofing is required. In case of clay, clay absorbs water. So the briquettes or the pellets formed after mixing bentonite clay, they are not water resistant. So you need to cure it. Heat curing is required. So large ash addition takes place. This is again a very important point, that by using inorganic binders, ash content increases. Secondly, there is no volatile matter addition into the pellets, because it is just inorganic. There is no volatile matter that will arise from bentonite clay. So the calorific value addition is not there. High temperature strength and thermal stabilities are there. Only thing is, it is not water proofed. It is water resistance is low, and what heat curing is required. In case of sodium silicate or water glass, at low temperatures, this is interesting point, sodium silicate also generates bond film and separates out silica acid gel particles, which enhances the strength of the briquette. So sodium silicate, these are categorized as industrial inorganic binders. They are cheap, no pollution, easy availability. So these are the inorganic binders for industries. They are sodium silicate is imparting a good strength to the briquettes, to the pallets. However, again, prevents formation of dust, but alone not suitable as commercial binder due to poor coherency. Again, alone it cannot be used as a binder. Secondly, it is also poor waterproofing. It is, again, you need a curing, thermal curing or heat curing is required for if you are using sodium silicate as a binder. Next is the MgO and MgCl2, that is magnesia cement. This is also acting as a binder, and very good thing is that it quickly forms, magnesium chloride present in it quickly forms and sets as insoluble cement due to the oxychloride of magnesium formation. The briquettes are hard but brittle. So again, means every binder has some advantage and some disadvantage. If it is giving you stability, then maybe the briquettes are brittle. If it is giving you more stability, more mechanical strength, then maybe the ash content is high. So you have to see, you have to balance your pros and cons, what exactly you need. In the similar way, this magnesium chloride, it loses chlorine in fire as free HCl vapor, so it is corrosive. So it has its advantages, it has its disadvantages. Again, inorganic binder, one is calcium hydroxide. Some of the researchers says that it has a very good binding capacity because I have written a reason also in this. Just a second. You can see here good mechanical strength. Why it is good mechanical strength? Due to the ionic bond produced from the dissolution and reaction of calcium hydroxide. Calcium hydroxide, when reacts with water, it will form again ionic bonds, and hardening and strengthening effect produced by the hydration of calcium hydroxide. So in pellets, they are giving good mechanical strength as per some of the researchers, while some of the researchers says that very weak mechanical strength. So we need to work on, we need to actually find out what exactly the strength is, which is the best suitable binder for us. It has the ability to capture SO2, which is evolved during coal combustion. So if you are using coal briquetting, if you are going for lignite briquettes, then one can prefer calcium hydroxide, because again, it will help in absorption of SO2. Similarly, magnesium oxide is there. This is also an inorganic binder. It has also a ability to capture SO2 evolved during coal combustion. MgO again imparts strength, strong briquettes form. In fire can withstand well. Like it should not burn. As you are putting a briquette or a pellet into fire, it should not doze off then and there. It should have a good burnout time. It should have a good combustion length. So it is not only one property that helps in choosing a binder. It is a overall pros and cons that we need to weigh while choosing a binder. And foremost is the cost of the binder and the availability. Then you have gypsum. Gypsum is again briquettes or the pellets are brittle, disintegrate rapidly in water, but withstand heat, impart slower combustion. So these are few inorganic binders I can repeat in one go. That is clay you have, then we have sodium silicate, we have magnesia cement, we have lime, we have this one more is iron oxide and calcium oxide. It gives high compressive strength. Magnesium oxide, gypsum, these all comes under inorganic binders. If we go towards the organic binders, then starch is very common binder. We have cellulose based binders. We have guar gum binder that is very common. Modified starch, then sodium starch glycolate and starch ether. And if you see the costing of these binders, these all are India Mart prices. It is 43, 55, 75, 44. Organic binders per kg are expensive. If you see for the inorganic binders, then the cost is around say 30 rupees. Even it is going up to 150 per kg. If we are talking about magnesium oxide, but other binders like lime, it is just rupees 5 per kg, 15 to 40 rupees per kg. So this is
They
how,
are very cheap.
yeah, inorganic binders are cheap. Whereas organic binders, they come with their own advantages as they are no smoke, no, non-volatile, so provide coherency in fire. But disadvantages is it is expensive. The very first thing is it is expensive. If you are seeing 44, 75, 55 rupees a kg, so we have to see where, what to mix, which property we need to derive basically. If we have to add volatility also a little bit, then that trade-off has to be worked out. Low waterproofing is required. The starch produces better results than asphalt emulsion or bentonite when mixed with 12 to 13% water. So starch is very common binder that most of the people uses, but yes, then the brackets is little bit pricey. Cellulose, if you see, it is 3 to 7%. Here also it is 4 to 8%, 2 to 6% starch is used in case of cellulose. 3 to 7% is used. Guar gum is used in less amounts also, up to 2.2%. Some literature mentions up to 6% guar gum. With every organic binder, cost is a major factor. Modified starch is even costlier. It is 70 rupees. So in organic binders, we can classify them into four types. We can call them as polymeric binders. We can call them as biomass-based binders. We can call them as lignosulfate-based binders and tar pitch or petroleum or bitumen-based binders. So biomass-based binders we have already discussed, in which starch can be of any type of starch. It can be tapioca starch, cassava starch, corn starch. So different studies have been carried out on different type of starch. There are percentages that has to be added, uh, like gelatin starch. These all comes under biomass-based binders. And if we talk of lignosulfate, then lignosulfate is a paper industry waste that is enriched with lignin, that is having a lot of sugars. And yeah, if we say lignosulfate, then it also act as a binder. Third type of binder comes in the form of polymeric binders, in which generally we talk about glycerine. So glycerine combustion at low temperatures encourages the formation of acrolein. That is a toxic gas. So glycerine combustion, glycerine as a binder, it is non-commercialized binders. So a lot of studies has been taken on this glycerine as a binder. It imparts various advantages also, but at the same time, at low temperatures, it forms acrolein. So we should not use it in the commercial level. Other binders, polymeric binders, that includes our PVA, that is polyvinyl acetate. Then we have styrene, acrylic and methacrylic acid esters, paraffin wax, latex is there, molasses is also there, cow dung, resins are also used. And again, I have, as I explained, the lignocellulosic binders, lignosulfate binders, that is a paper industry waste binders. So these are the 4 different type of organic binders. Inorganic binders we have already discussed, that are used in pelletization. Thank you.
The bio oils or the oil waste from the oil mills, even edible oil mills, the cake and other things can also come into the picture.
Yeah.
The
That
bio oil from the biochar itself, can it go as a binder if you want to add on? That is one question.
Yeah. That also act as a binder. There is one more class of binders, tar pitch or petroleum, bitumen. So these all are coal-based, like asphalt, heavy residue from the petroleum industry. Coal tar pitch is there, fine wood tar. So this forms under tar pitch or petroleum binders, you can call it, that involves from wax tailings or refineries. जो हमारे refinery के अंदर different waste comes out, so they can also act as a binder. In plastic pyrolysis units, some very thick, viscous, waxy substances come out during pyrolysis. So apart from lighter fractions and apart from hydrocarbons, so they are mixing their char with that waxy substance to increase the calorific value as well to give the binding properties to the char. So pine wood char, or you can say the bio oil itself, can act as a binder. That has 2 benefits. It adds to the calorific value and act as a binding agent.
Good. I think you gave a broad spectrum based on the availability and the even the machinery and the applications. So there can be hundreds of products in this domain of biochar pellets, which can be used for various purposes. Ultimate applications. One application is as a combustion when we are using that has a different value as a biochar also. The terminology can also vary because biochar we mostly use when we are not burning, otherwise mostly. So second thing is when we are applying these pellets, biochar pellets to the environment, definitely the inorganic or polymer binders are bad because the degradation or their non decomposition nature and other things. So as residue they might remain. Whereas the organic binders right from lignin, cellulose or gum from trees or anything, all these things will definitely will not create any negative impacts. So that much we can understand maybe based on these binders. Of course, the cost, as you said, the inorganic binders can be competing in a way because they are less costly. But ultimately, when we look at the applications or the calorific values or volatiles or the smoke or residues and environmental considerations, there were various choices can be made in the whole process. Yes. So yeah, finally, I think yeah, this biochar pelletization is an important topic where additional livelihoods can be created, including when we are looking for co-firing with the coal, even the thermal power plants or and for energy decentralization or sustainable energy solutions, reuse recycle concepts can we bring. I think biochar pellets are very promising. I think we can explore many advantages in the future too. Thank you very much, Dr. Sonal Garg. As like any other discussion, even this discussion you have enriched with your experience as well as your own PhD and research work. This adds lots of value to the listeners. Thank you very much.